I did it. As I mentioned, after imaging the moons of Uranus, I wanted to try imaging the moons of Neptune. I wasn't sure it would be possible, and I assumed it would be the biggest moon, Triton. But surprisingly, I captured Nereid, which is the third largest moon of Neptune. Who would have thought that was possible with a small refractor? Welcome to Virtual Pathfinder channel. I make videos about imaging and especially astrophotography. If you're interested in exploring the universe with your camera, remember to subscribe to this channel. I use affordable equipment which can reach distant galaxies as well as detailed structures on the moon. Now let's have a look at today's video. Yes, I captured Neptune's moon Nereid. Let's have a look at it. It was discovered in 1949 by Gerard Kuiper using an 82-inch telescope. As a side note, my telescope is tiny in comparison, just 2.8 inches, which corresponds to 72 millimeters. The name of the moon comes from the Greek mythology, where the sea nymphs were called Nereids. They were said to be attendants of the god of the sea, Neptune. That was the second and last moon discovered by observation before Voyager 2 visited Neptune in 1989. Nereid has a mean radius of 180 kilometers or 110 miles, which is very small. It has highly eccentric orbit around Neptune. Water and ice has been detected on the surface. Neptune itself is the planet at the edge of the solar system. It takes about 12 years to get there. It is 30 times further away from the Sun compared to Earth. It takes the light from Neptune on average 4 hours to reach Earth. So why is it difficult to image Nereid? That is because it's very small and very faint. The visual magnitude is a logarithmic scale where the higher number means fainter objects. A difference of 1 step lower on that scale corresponds to an increase in brightness of about 2.5 times. The limit what can be seen by the eye is about magnitude 6, which is about 6 times the brightness of Neptune. But Nereid is extremely faint, with about 24,000 times less brightness than Neptune. So very few photons are landing on the camera sensor, which means that it can easily drown in noise. A word about my equipment. I use an ordinary photography tripod of good quality, able to carry a payload of about 12 kilograms. Never use flimsy tripods. It's not possible to achieve sharp images with long exposures using those. Stability is more important than anything. Then I use a tilt head with a star tracker attached to it. That is necessary to track the celestial objects in the sky as they move. I use a Vixen Polari, which is a compact star tracker. I power it from a power bank. On top of that, I attach a counterweight bar, which holds a weight on one side and my telescope on the other side. The telescope is a Skywatcher EvoStar 72 ED, which is a small refractor, which has glass with low chromatic aberration. Although it's not an apochromatic refractor, it's not far from it. Considering the cost of it, it performs very well. It has a focal length of 420 millimeters and bright optics with aperture ratio 5.8. I can't say enough how much I love bright optics. It makes life so much easier, shortening the exposure time, which reduces the requirements on polar alignment and so on. Powerful telescopes usually have less bright optics, but that can be overcome with hard work or by looking at bright objects, such as planets. I think this telescope makes it easy to take snapshots to see if I'm aiming in the right direction. I have a Micro Four Thirds camera attached to the telescope using a T adapter. A dedicated astrophotography camera can probably produce less noisy images, but I use my ordinary camera, which is an Olympus OMD EM5 Mark II. That is a Micro Four Thirds camera which has a crop sensor with a crop factor 2, corresponding to a quarter of the sensor area of a full-frame camera. I find it fantastic that I can use the same camera for nature photography, astrophotography, or photography at social gatherings. Enough about the equipment. So how did I do this? After almost a month of cloudy skies and rain in November, the skies cleared up last Friday. It created an opportunity I've been waiting for a long time. Quickly, I had a look at the app Sky Safari Pro on my iPad to see where I can locate Neptune. I was lucky since it was quite near Saturn, which is easy to find. It rose early in the afternoon, and since it was dark early, it was possible to find it in the southeast direction. So I assembled the rig on the south side of the house, which means I could not make a polar alignment using the North Star Polaris. Instead, I set the tilt head to the latitude of my location, and then normally I would have used a compass to aim the axis of rotation in the northern direction, but this time I used my memory of direction, which turned out to be quite accurate. I started the motor of the star tracker and aimed at Saturn. From there I jumped from nearby stars to find Neptune. I set the camera to high ISO and used the live view function to see what the telescope was aiming at. I took a snapshot to make sure that I had Neptune near the center of the image. I want to mention that the temperature had fallen well below freezing at that time, and although I had put on warm clothes, I used mittens with half fingers. I was freezing my fingertips and got numb after a while. But who cares about that if you can have the chance to capture the moons of Neptune? I took several shots, and it is tempting to go for the maximum ISO value since that generates bright images. But there is a trade-off when doing that, since the high ISO images get very noisy. When imaging small faint objects, that is a problem. So I wanted to have as low ISO value as possible without getting too long exposure times. Long exposures are difficult, especially when the polar alignment cannot be done with precision. So I settled for ISO 1600 and managed to get a 40-second exposure with acceptable quality. I tried some combinations with other settings, but the one I used was the best option for small faint objects. After shooting some images, I did some post-processing to get the small faint objects to become visible. I was looking at the alignment of the moons at the time of capture in Sky Safari Pro and worked my way to get the moons to come out of the noise by adjusting the processing. Here I would like to point out that it would have been better if I shot a series of images and stacked them, but I didn't have the time to do that, so I settled for a single frame this time. As I mentioned, it was literally freezing cold. After a long session in temperature below freezing, it was fantastic to have a cup of tea to get warm again while image processing. Lo and behold, after zooming in on Neptune and processing the image, Nereid came out of the noise, but it came out as a very dim and small object. Still, it is clearly visible at the location it was supposed to be at according to Sky Safari Pro. Triton was too close to Neptune and was likely drowned out in the light from the planet. But it feels like a greater victory to capture the third largest moon instead. This is at the edge of the solar system, which is fantastic. If I get another chance soon, I will try to stack images and possibly get the other moons, Triton and Larissa. Anyway, that was all for this time. If you like this kind of content, remember to subscribe to this channel. Then we can explore the universe together. See you in the next video then. Have a good day and many starry nights.